I will begin in the Fiber Data Hub by listing its available repositories. SCA2 is a disease dataset, so I will search the first open neurodisease repository for dataset DS001378. The SCA2 release is available. I will read its release note to verify the study contents before downloading anything. This release contains 9 patients and 16 matched controls scanned twice. I will now list its downloadable reconstruction and demographics files. The empty file name filter was ignored by the launcher, so I will repeat the listing with an explicit match all expression. The shell expanded the asterisk before DSI Studio received it. I will use an equivalent expression that contains no shell wildcard. I will download the 16 Session 1 Control QSDR reconstructions into the selected SCA2 working folder. The 16 control reconstructions are downloaded. I will now download patient SCA201 at the matching first session in native space GQI form. I will set DSI Studio's working folder to the downloaded SCA2 files so later batch commands use simple reproducible paths. The quoted path was parsed incorrectly. Because this path has no spaces, I will repeat the folder selection without nested quotes. I will first export DTI fractional anisotropy from one control to verify the exact export operation before batching all controls. The test export succeeded and confirmed the metric name. I will now batch export DTI fractional anisotropy from all 16 aligned controls. All 16 control FA maps are ready in the same QSDR space. I will average them voxel by voxel to create the control reference. The 16 control FA average is complete. I will now open patient SCA201's GQI reconstruction for native space tractography. Because the control average is in MNI space and the patient is in native space, I will add it as an MNI slice so DSI Studio maps it correctly. The MNI mapping finished. I will inspect the slice list to confirm the control average map is ready and capture its exact runtime name. The control map is ready. I will inspect the first differential metric menu to find the exact index for the control reference. The control average is differential index 9. I will inspect the second menu to confirm the patient's own DTIFA index. I will define damage as fractional Fa loss, control average minus patient Fa, divided by the control average. The differential expression is correct. I will inspect the current tracking settings before choosing the damage threshold and tract count. The settings already use a 20% Fa loss threshold, 10,000 tracks, and no automatic tip pruning. I will explicitly preserve those values for this run. I will now track whole brain pathways where SCA201 has more than 20% lower Fa than the control average. Differential tracking is running. I will check whether the damaged tract map has finished. Tracking is complete. I will inspect the resulting bundle count before deciding whether light cleanup is appropriate. The raw map reached 10,000 tracts. I will apply one topology-informed trim, then inspect how much coherent anatomy remains. One trim round is applied. I will check the surviving tract count and deleted trajectories before any further cleanup. The first trim removed no trajectories, so the map is already topologically stable. I will ask the tract atlas which named pathways overlap this damage pattern. The indexed recognition request did not return the ranked names through this launcher. I will repeat recognition on the currently selected bundle without an index argument. Atlas recognition shows the strongest overlap in both cerebellar hemispheres, the middle cerebellar peduncle, and the vermis. I will prepare a clean three-dimensional anatomical view. I will add a translucent white matter surface to provide anatomical context around the damaged pathways. The anatomical surface is loaded. I will inspect the rendered tract and surface layers before saving the final images. The rendered map is centered in the infratentorial white matter, consistent with the atlas ranking. I will save the native space tract bundle for later analysis. I will save the tract atlas recognition table so the affected pathway labels and overlap percentages remain reproducible. I will save paired left and right anatomical views of the damaged tract map at presentation resolution. The bundle and images are saved. I will collect quantitative tract statistics for the final interpretation. The mapped pathways average about 34 mm long and occupy roughly 53,000 cubic millimeters. I will save the complete statistics table. The SCA201 damage map is complete and verified. The strongest affected pathways are bilateral cerebellar fibers, the middle cerebellar peduncle, and the vermis. I will post the saved outputs now.